To better understand how the urban nexus of water, energy, and food emerges or not, I offer and explain a conceptual framework based on networks and flows as developed in sociology by Castells. The framework aims to provide guidance on identifying and understanding the connectivity of water, energy, and food. Cities and social life are organized through networks. Water, energy, and food are resource systems that feed cities through networks of provisioning. For example, think of the city you come from, its food markets, and the food networks these are connected to. Networks organize and deliver flows of water, energy, and food resources. But what are flows and networks about? And what are these for? Flows are the streams of information and resources that circulate between and through networks. Flows are the streams of not just material resources, for example, cubic meters of water or kilograms of food, but also flows are the information, policies, practices, and any kind of socio-cultural expression in general that circulate between and through networks. A network is an organizational structure that results out of a set of interconnected nodes. Nodes are all the social and material components of a network. For instance, actors, processes, policies, power plants, and so on. For example, food markets are organized through global food networks, supplying food from all over the world into cities through processes of production, transport, wholesaling, distribution, retailing, consumption, and waste collection. At the same time, food networks and flows closely relate to water and energy. For instance, what type of energy powers food retailing, or what water irrigates food production, or how does food safety standards interact with energy consumption patterns in food retailing. To better understand how connections and interactions between water, energy, and food networks and flows occur, I will provide you with a set of concepts to analyze the nexus. Networks have three main components: structure, function, and power. I will explain three of the structural components of networks. These are scope, connectivity, and density. The scope of a network indicates how extended the reach of a network is about, and what the variety of flows and actors in the network is about. For instance, in the food sector, the scope focuses on urban agriculture projects and practitioners that self-generate food within an urban setting. Or it can also focus on the global food system, which produces food for markets all around the world. Nodes are connected by flows. How nodes operate more or less central in the network, and how different nodes can be connected in more tight or loose manners refer to connectivity of networks. For example, the structure of an urban agriculture network is determined by how it connects or not nodes of farmer markets, consumers, and local food providers. Networks are then characterized as dense in terms of the frequency, time-space dynamics, and the robustness of their flows and connecting nodes. For instance, networks for the provisioning of urban food are not only connected through food processes of provisioning. For instance, food is also connected to standards, regulation, or human rights. At the same time, food is also connected to water and energy regulation and practice. Water, energy, and food networks are then considered densely connected, for example, when a myriad of actors, flows, resources, and projects, in general terms a critical mass, connect to actually deliver provisioning services that account for more resource integration. Think about seasonal food coming from the proximity of the city, distributed through sustainable means of transport, and through sustainable food markets. In the context of the Nexus, questions around the compatibility, connectivity, and density of scopes between water, energy, and food networks play a very important role. Next to the structural components just explained, networks also relate to functional components. These are values and goals, and these respond to what networks are for. The function of a network refers to the set of values and goals that the network is aimed to achieve. Networks result from the interaction of social actors pursuing common values and goals. These guide actors into the creating, organizing, and reconfiguring of networks. For example, in the context of governance strategies for urban climate neutrality, networks and flows of water, energy, and food interact with each other based on unifying values and goals for neutralizing the anthropogenic impact of cities in their commitment towards sustainability. Think again the previous slide. What if the different societal actors from water, energy, and food in a city establish common values and goals to warrant the provisioning of seasonal food coming from the proximity of the city through renewable energy-based means of transport? Are function and structure components enough to analyze social change through networks and flows? Well, next to structural and functional dimensions, whether or not and how networks emerge across water, energy, and food sectors is also shaped by power dynamics. I will elaborate on 4 different dynamics. First, networked power. This relates to the concentration of power by actors dominating the processes of decision and policy making of water, energy, and food sectors, but it also relates to the actors establishing the rules for inclusion and exclusion to these networks. For example, think about large retailers influencing global food chains, but also think about influencing practices of how we produce, transport, and consume food. For instance, think of supermarkets. Second, network power. Networks are programmed with rules. This relational capacity of power implies that coordination between actors or networks relate to the imposition of rules or standards that determine the inclusion of new members into networks. For example, think about strict food safety standards for food retailing and its implications on high energy consumption for its refrigerated food transport and retailing. Do these standards facilitate new ways of sustainable food transport to emerge? Third, networking power. This is the capability of certain actors for actually including or excluding new members from existing networks. Inclusion and exclusion is based particularly on the extent to which the scopes, values, or goals of the incoming members are compatible with those of the actors already included in the host network. For instance, think of the previous example about food safety standards. Then, think about food distribution via bikes to lower energy consumption in food retailing. For some types of food distribution, food needs to be transported refrigerated. Think about fish. For alternative distributors, for example bikes, this represents a challenge that limits their food distribution services. In terms of networks connectivity, this can be an example of incompatibility of functions between food and energy networks that prevent sustainable alternatives to further emerge. Then, the last form of power is network-making power. This refers to the capabilities of actors to create and program networks. These actors influence both the structure and function of networks by reconnecting actors and nodes and by reconfiguring the goals and values that networks want to work with. For example, organic food labels. In a way, reconfigure the actors and processes involved in food provisioning. These capabilities rest with groups of switchers and programmers of networks. These actors are crucial to further identify the points of connection or disconnection between actors, flows, and processes of water, energy, and food provisioning in cities, but also at the regional, national, and global scales. Cities, in their quest towards more sustainable development, can benefit by understanding how their resource systems interrelate, but also by understanding how the actors, networks, and flows interact with one another in achieving urban sustainable development. I thus argue that understanding the interaction and compatibility of structures, functions, and power dynamics of networks is key to understand how to reconnect and reconfigure water, energy, and food into more sustainable outcomes in a time of rapid urbanization and climate change.